In this lesson, we're going to use an equation to graph the absolute value. There are two ways of doing this. The first one is by making a table. And you're going to identify the vertex here. So let's go ahead and just write our A, H, and K down. So A is 2, and our vertex HK, remember we have to do an opposite, it's X minus H, so H is positive 2, and K is the value listed there, so it's 1. So I'm going to put my vertex in the center of my table, so it's 2, 1. And I want to pick two values before that. So two values smaller than 2 might be 1 and 0. And two values larger than 2, I'm going to do 3 and 4. And then plug these into your equation. And so when I do that, this will be 0 minus 2, which is negative 2. The absolute value of negative 2 is positive 2. Times 2 is 4, plus 1 is 5. So you have to substitute it into the equation and find what y is. Plugging in negative 1. Negative 1 minus 2 is negative 1. Absolute value of that is positive 1. Positive 1 times 2 is 2. Plus 1 gives you 3. I plug in 3. 3 minus 2 is 1. Absolute value of that is 1. Times 2 is 2, plus 1 is 3. And then when I do it for 4, 4 minus 2 is 2. Absolute value of that is 2. Times 2 is 4, plus 1 is 5. So here is our table. I'm going to plot my points. So at 0, I am at 5. 1, I am at 3. At 2, I'm at 1. 3, I am at 3, and then 4, I am at 5. And so here is my graph. For fun, if I wanted to include the axis of symmetry, it goes through the vertex. And that vertical line is x equals, and the x value for the vertex is 2. So that is our line of symmetry if we wanted to include that. The second way, which is by far my favorite, is to go ahead and write A, H, and K down. So A is 2. And our vertex we already decided was 2, 1. Plot your vertex. And the slope of the right side is 2. So from my vertex, it's going to go up 2, right 1, up 2, right 1. There's the right side. And the left side is going to be the opposite of that, so it's negative 2. So it's going to go up 2 and left 1. So positive 2 divided by negative 1 is negative 2. So you're flipping it over that line of symmetry if you want to think of it that way. It makes the V shape. And again, if you wanted to include the line of symmetry, it's right here. And that line of symmetry is x equals 2. For this problem, if I wanted to include domain and range, notice it goes left forever, right forever, so the domain would be negative infinity to positive infinity. And the lowest the y value goes is 1. So my range would have been a bracket with a 1 to infinity. Let's look at this question here. What are the coordinates of the lowest or highest point on the graph? Those are going to be your vertex. And how can you tell whether this point is the lowest, a minimum point, or the highest, a maximum point, by looking at the equation? So if A is positive, that means my graph opens up. So it looks something like this. Here is my vertex. And in this case, it's going to be a lowest point. Which is a minimum. If A is negative, my graph opens down. Here's my vertex. This time it's a highest point. Which is called a maximum. And that occurs at the vertex. So if you look at your equation, you'll know if you have a maximum or a minimum by just looking at the A value. Let's go ahead and practice some of these. On this one, my A value is -1. HK, you have to do an opposite for H, so it's -1, and K is 0. So my graph, I'm going to go to -1, 0, and plot a point. And the slope of the right side is -1, so it's going down 1, right 1. So let's plot a bunch of points. And I don't have to plug anything into the equation if I use the graphing by transformations instead of a table. The other side is just reflected over that line of symmetry. That line of symmetry, if you want it, is x equals -1. And my slope of this side is +1. So it's going down 1, left 1. A negative divided by a negative would give you a positive slope. So here's my graph. So it has reflected over the x-axis. And my graph has gone left 1 unit from the parent function. I knew that it had a maximum from the equation because it was negative, but you could also look at your graph and see it has a maximum. The value of the maximum is 0. It's your y value of the vertex. Your domain from left to right, remember it goes smallest to largest, so it's -infinity to +infinity. And you always use parentheses for the infinities. Your range is low to high, floor to ceiling. This graph goes down forever, so it's -infinity, and the highest it reaches is your y value of your vertex, which is 0, because that was your max. On the next example, A is 7, HK is opposite here, so it's going to be +3 for H, K is -4. So at 3 and -4, you're going to start your graph. The A value is 7, so it's going to go up 7, right 1, up 7, right 1. And then the other side, you're just going to reflect that. And so here's your graph. If you want to put in the line of symmetry, you can. It's right here at x equals 3. And your graph looks something like this. It's a vertical stretch on this one. The graph has gone 3 units right. And then down 4 units, so it shifts down 4. I knew at the equation, since A was positive, that this one's going to have a minimum, but you could also look at the graph for that. The value of your minimum is the y value of the vertex, which is -4. Your domain's a freebie, -infinity to +infinity for the absolute values. The range, it's floor to ceiling. The lowest it goes is your y value. And the y value, the lowest the y value goes is from the vertex, which is -4. It does touch the vertex. It's included, so it's going to be bracket -4, and then it goes up forever after that. My next graph, A equals 2.5. I'm going to write that as 5/2. And then my HK is 0. There's nothing in here with X. And then K is 7. So 0, 7 is located right here. And it's going to go up 2.5 spaces and over 1. I'm just going to go 2.5. I kind of like to go even spaces. So I would rather go up 5 and write 2. We're going to run out of room on our graph though. So our graph looks something like that. And my graph has a vertical stretch since 2.5 is greater than 1. And then the graph shifts up 7. I knew from my equation, since A was positive, that it has a minimum, or you could look at your graph. Again, the value of your minimum is your y value of the vertex. Which in this case is 7. Your domain is -infinity to +infinity. And your range is floor to ceiling. And the lowest y value it goes is 7, and that's included. And then it goes up forever after that. Okay, for the next few problems, we're going to go ahead and write our equations looking at the graph. So A is 1. So it's going up 1, right 1, up 1, right 1. My HK value is 1, 0. So my equation is y equals 1, which I don't need to put in there, times the absolute value of x minus h, so -1. And k is 0, so +0 on the outside if you want to. Domain is a freebie, so -infinity to infinity. This is going to have a minimum value since A is positive. And so the minimum is where it starts for your range, and you use the y value. And the y value of that was 0. And I can even look at my graph. The lowest y value it goes is 0. The next one, let's go ahead and write A, H, and K. A is -1 in this case. HK is 3, 0. So my equation is y equals absolute value. Oops, I need my -1 there. -1. Absolute value of x minus h. And then 0 is k, so +0. I'm not going to put the +0 there. My domain is negative infinity to infinity. Since A is negative, it's going to have a maximum, and you could see that from the graph. The lowest it goes is negative infinity. You have to start with your low first. So this is going to be negative infinity. And the highest it reaches is the y value of the vertex, which is 0. And I can look at the highest it reaches is 0. You're not looking at left and right. You're looking at the y value. For C, A is equal to 1. And HK, this case, is 0, negative 2. So my equation is y equals 1, which I don't need, times x minus 0, so I don't need to put that in there. And then k is minus 2. If you want to put the multiplying by 1 on the outside, that's fine, but it's not the simplest form. If you put the 1 there, it's not needed. Same here. I wouldn't put the minus 0 because x minus 0 is the same thing as x. Your domain is negative infinity to infinity. Your range, since A is positive 1, it's going to have a minimum. And the minimum value is your y value from your vertex, which is negative 2. And then it goes up from there. On the next one, A is 1. HK is 2, 2. So that's my vertex. So A was going up 1, right 1, up 1, right 1. And your vertex is 2, 2. Your equation is y equals x minus 2 plus 2. So you're plugging in your A, H, and K. Your domain is negative infinity to infinity. And your range is floor to ceiling. Your lowest y value you get from the y value of your vertex. So the range is 2 to infinity. And 2 is included, so you have to have a bracket. Infinities always have parentheses. Okay, now I'm going to start with y equals x minus 6. And I'm going to move it and change my graph to y equals 1/2 x plus 8. So the first thing it's done, the a went from a 1 to a 0.5. So the a value got smaller, which means it's a vertical shrink. And it was 6 to the right. So it started out at 6, and it ends up with h at negative 8. And so if you do 6 minus negative 8, you'll see that's a difference of 14. So it went 14 units to the left. And then on the next one, it went from 1 to 2, which means the a value got larger. So this is a vertical stretch. And if this had been negative 1 and negative 2, you don't pay attention to the signs because that has nothing to do with the vertical stretch or shrink. It decides if it's going to open up or down, if it's reflected over the x or not, if you have a negative. So I have a vertical stretch on this one, and it started at 0, 0, and it ends up at 3, 0 for my vertex. So this graph has moved 3 units to the right. And I think I said it, but this is left 14, it's shift left 14. And that completes our notes for the day.